Woohoo! Welcome back. Today we're going to be working once again with 3 by 3 systems, which means 3 equations in 3 variables to answer the question, will Matt Damon get to come home? And I'm going to remind you that these are linear equations, but the interesting thing is I don't think I've said it yet. These aren't descriptions of lines. When we've got 3 dimensions, 3 variables, we're actually talking about planes. And this is something that we in this class are not going to be graphing, but if you continue on with math, it is something that eventually you start to look at. So that's something to look forward to. For us, we're just going to look at these as being equations, requirements, and so there are 3 different variables, and we're looking for 1 or more solutions that will work in all 3 equations. Woohoo! So the way we're going to approach this is by something called Gaussian elimination. And in order to do this, I'm going to name each of the equations. Pardon me. And as before, I'm going to name it row 1, row 2, and row 3. And this may be bothering you, like, why are we calling these rows? And this is to set up for what's to come next, because the next step is going to be putting these numbers, the coefficients, into a matrix and solving them without having to keep writing x and y and z over and over and over again. But that's where we're going to. You can name the 3 anything you'd like. I think this is just a nice way to keep track of your work. When we go through, especially a problem like this, and this one's going to be nice and challenging and long, when you go through a problem like this, it's really great to be able to record what you did. So you don't have to use my method, but definitely try to remember to just remind yourself what steps you're taking. Be very clear so that if you do have a problem where you stumble, you can go back and you don't have to start everything from scratch. Okay, so let's get going. As before, I'm going to be looking for triangular form. So I am looking for a situation where I eliminate this x, and this y. And you can do this in a lot of different ways, and we will continue to explore this even when we move into matrices. So, but I noticed that this x right here is just 1x, which is really nice. So I'm going to use this 1x to get rid of the 2 x's below it. So this is how I'm going to do it. I'm going to go ahead and get started with row 2, I think. Row 2, I'm going to go ahead and take row 2 and then minus 2 row 1. And of course, I'll remind you that technically this is plus the opposite of 2 row 1. So you can write it that way. I find that it's more confusing that way. So I'm going to write it as subtraction, even though we are all agreeing that we're adding the opposite. And then when I've got row 2 and row 1 in play, I can put this in either row. I'm going to use this to replace row 2. So this is going to look like row 2, which is 2x plus y plus 4z equals 2. And then I'm going to multiply by negative 2. I'm going to take the first row and multiply by negative 2. So that's going to be, so there's row 2. Here's negative 2 row 1 is going to be negative 2 times x is negative 2x. Negative 2 times the opposite of y is positive 2y. Negative 2 times 5z is minus 10z. And negative 2 times negative 2 is 4. And you can see that when we're going through these, there's so many opportunities to make little mistakes. So keep in mind that the point of this is to learn the process and try not to be to feel too frustrated if the details, like there are so many moments when you can accidentally multiply incorrectly or you just get one little number off, and then it can be very frustrating because these are long problems. So if you run into a wall, please reach out for help right away. Okay, so I'm going to take row 2 plus the opposite of 2 row 1 and that's going to cancel out my x's, so I got a big 0 there. Then I get 3y minus 6z equals 6. So I'm going to go ahead and take that and put that into row 2. So my new system is going to be row 1 is x minus y plus 5z equals -2. My new row 2 is going to be 3y minus 6z equals 6. And my old row 3 is 2x plus 4y minus 2z equals 8. Okay, so then I'm going to use row 1 again, and use row 1 to get rid of this. This is what I want to aim for next. Okay, so I want to get that out. And so I'm going to take row 3 and subtract, again, 2 row 1 and put that in row 3. Okay, let me squish this up. So I've got row 3, which is 2x plus 4y minus 2z equals 8. And the opposite of 2 row 1, which is going to be -2x plus 2y minus 10z equals 4. And you'll notice, let me squish this down a little bit, I already did this since I haven't changed row 1 yet. I did that right there. So I'm doing the same thing twice. I'm using this so I can double check my work this way. It's kind of nice. Doesn't always work out that way, but you know, small little presents from the universe. So 2x minus 2x, 0. 4y plus 2y is 6y. And then minus 12z equals 12. Okay, so now I need to regroup. This is my new row 3. And in fact, I didn't write that here, so before we switch the page, let me go ahead and go back and say this is the new row 2, so that it makes our work easier to follow. On the next page, I'm going to write up my new system. So my new system is the same as the old system. Row 1, x minus y plus 5z equals -2. Row 2, no x, 3y minus 6z equals 6. And row 3, and then I'm going to get my new row 3 from what I just did. So my new row 3 is going to be no x, 6y minus 12z equals 12. Okay, so now I've got my new system. Yay! Which is equivalent to the old system. It's just one where we're going for that, we're going for triangular form. Remember, triangular form has a 0 here, a 0 here, and then another 0 there. And so I want to get rid of this. So I look at all of my options and I see that I could use row 1 to get rid of this 6y, but because of the x that's in row 1, that would, and here I have a funny way, the way that I learned to talk about it, that would reinfect row 3 with x's, as if all the variables are viruses, which honestly, after you've been working with these for a while, the variables start to seem a little bit like viruses. So I'm not going to use row 1 because row 1 has an x. That's just going to mess everything back up. Row 1 gets to rest. It's been working hard. I'm going to look to row 2. And there are a couple of options here. I could take row 2 and divide everybody by 3, right? Because that would be nice and clean and get it down to y minus 2z plus 2. That would be a great thing to do. Or I can use it as is and go ahead and say, well, I could take row 3 and subtract 2 of row 2, because 6y minus 2 times 3y would be 6y minus 6y. That would get rid of the y. And so that's what I'm going to do. But here's one of those decision points where some people would say, nope, go ahead and divide by 3 first. And I would say, divide by 3 if you'd like. But if you can use it the way it's written, then I would go ahead and leave it like that. It's up to you. This really is a choose your own adventure. So I'm going to take row 3 and I'm going to subtract 2 row 2. and put that back in row 3. Okay, so I've got row 3, which is 6y minus 12z equals 12. And negative 2 row 2 is going to be, again, multiply by negative 2, negative 6y plus 12z equals negative 12. Now, your brain is going to tell you, warning, Will Robinson, danger, danger. And you've got to ignore it a little bit. Thank you, brain. Say, thank you so much, brain. You're right. There's something interesting happening. But I would encourage you, do not jump ahead. Try to stay where you are with the math. I am noticing it too. There's some funky stuff happening. And let's go ahead and, so don't just stop in the middle and go, everything's broken. Everything is not broken. The 6y minus 6y gives us a 0. The negative 12z plus the 12z gives us a 0. The 12 plus a negative 12 gives us a 0. Now, here's where things get interesting. Is this true or false? Well, I think 0 equals 0 is true, right? This is absolutely true. And so what's happening here is that we're finding out that we've got 2 pieces of information that are actually matching up. So here when we originally faced the problem, back here, we thought we were given 3 completely different pieces of information. And here we're finding out, oh, some of it is duplication. And so this is good, right? Let's review what a true statement is. A true statement means that we have a dependent system. Now, these are not lines, these are planes. And so what's going on in a dependent system is a little bit more complicated than when it's lines. Remember, when it was lines, it was just 2 lines of the same line. And a dependent system means that you've got some duplication of information, but I will leave the rest of that conversation to a later class. But if it's a dependent system, the answer depends on getting more information. So right now, actually, we've got happy Matt Damon. Oh, he's all curly. You can tell it's kind of humid today. Yay! He's so happy he's curled up. Little dance party. So a dependent system means we have an infinite number of solutions. So Matt Damon is coming home. Yay! The problem is that Matt Damon is going to have to make some decisions. That might be stressful, but ultimately, yay, we've got an infinite number of solutions. So we're all very excited. This is very exciting. And but unfortunately, the problem is that now we have to figure out how to give our information. So what do I mean by that? How do we write our solution? Well, as a solution, you definitely want to write that it's a dependent system and there are an infinite number of solutions. But then you have to give an outline for how to find the solution. And so what we're going to do is we're actually going to come down here and we're going to say, okay, what have we got? So the last thing that we had this. And basically what we were told is these 2 equations are basically the same equations. So these two equations do describe lines at this point. When you've gotten rid of the x, we got lines, right? It's just a y and a z. But they actually are the same line. So we don't have enough information. If we discount the duplication, we just have these 2 equations. So we've got to craft a solution from these 2. So this is what we're going to do. I'm going to take this row 2, and write 3y minus 6z equals 6. Okay, so we've got that. And then I'm going to say, okay, well, I'm going to say let z equal t. Now, this is going to feel kind of weird, and we're going to explore this more. If you go into calculus, you will explore this more. This is something mathematicians love to do. They pick another, so that we're not, putting everything in terms of z. We're going to pick another variable. Frequently, it's something like t. And t is very common, and we're going to write the whole answer in terms of t, because basically we can't narrow the answer down to a single point. So let's let z equals t. Okay, so you're saying, oh, okay. So then, come here. So then, I'm going to write that row 2 gives us 3y minus 6t equals 6. I'm going to add 6t to both sides. And I'm going to get 3y equals 6t plus 6. And then I'm going to write y by dividing both sides by 3. So now oops, sorry, you can't see that. So now I've got y in terms of t as well. And then row 1, and this is just like if we had found out that z equals 5, we'd be doing the same work, except instead of getting expressions like this, we'd be getting numbers. So it's the same thing, except instead of a number, we're using t. So now I have to be very careful. I've got x minus, now y is going to be 2t plus 2, because that's what we figured out y has to be from the second row. And then we already know that z is t, because that's what we said. And then we've got negative 2. Okay, so this is x minus 2t minus 2 plus 5t equals negative 2. So x, I'm going to combine the t's, plus 3t minus 2 equals negative 2. Oops, again, I ran out of space. Sorry about that. So I'm going to combine the t's and get plus 3t, and then minus 2 equals negative 2. Add 2 to both sides to move. So I'm going to move everybody over to the right, solve for x, and I get x plus 3t, and it turns out it's really convenient because it's 0. So then we just subtract 3t, and we get x equals negative 3t. So our solution is x equals negative 3t, y equals 2t plus 2, and z equals t, which, believe it or not, I can write as negative 3t, 2t plus 2, and t. Now, what does this mean? Well, this means I could pick a value for t. So if I want t to equal 1, then my points would be negative 3, 4, 1. That would be the solution. So Matt Damon gets to pick the color of the spacecraft again, and we can get him home just fine. He just has to tell us, does he want it in blue? Does he want it in red? If he wants t to be 2, then we get negative 6. 2 times 2 is 4 plus 2 is 6, and 2. So there are an infinite number of solutions, of possibilities here. Woohoo. So, again, please reach out. Ask lots and lots and lots of questions, because this stuff is kind of wacky, but it's very cool, and it does get easier with practice. And the promise is, in the very next chapter, we're going to get rid of the variables, because, oh my gosh, so many variables. We're just going to use the numbers, and it's going to simplify things, and you're going to get going really, really fast with these. So Take a break, get something good to eat, rest your eyes, do some, reading, some literature, do some dancing, make some art, sit down and, mix up some chemistry, whatever it is that you do to relax and have fun. And I will see you in the next video. Woohoo! And math on.